In this video, we're going to do an example of using logarithmic properties to combine logarithmic expressions. So we're asked to combine each of the following into a single logarithm. So the first one asks us to put 4 plus 2 log base 3 of x minus 5 log base 3 of y as a single logarithm, a log base 3 of something. Well, the second two terms, we're going to be using our log properties. We can bring the 2 up on the power of x and the 5 up on the power of y. So we get the log base 3 of x squared minus log base 3 of y to the 5th as our second two terms. So we're just bringing the constants that are out in front up inside as exponents. What about this 4? Well, I can use the fact that log and exponential functions are inverses of each other. So if I do log base 3 of 3 to the 4th, here's the logarithmic function, here's the exponential function of the same base, they undo each other. So I can rewrite 4 in that fashion. Now we're ready to combine things together. The first two are added together, so that's a product of the insides here. So we got log base 3 of 81x squared minus log base 3 of y to the 5th. And now since we have a difference of logs, we're going to rewrite that as a quotient. So our final answer is log base 3 of 81x squared over y to the 5th. The second one's asking us to combine 1/3 times the quantity 2 log x minus log y minus z. First thing we'll do here is take this coefficient that's out in front of the log x, move it up as an exponent, so we get 1/3 the quantity log of x squared minus log y minus log z. Looking at the first two expressions now, they're subtracted, so that means I can rewrite it as a quotient. So I get log of x squared over y on the inside. Again, inside these parentheses, we have a difference, so that means I can write this as a quotient as well. So now we have 1/3 log of x squared all over y times z. And then our final step that we can bring our 1/3 up as an exponent, and remembering that a 1/3 exponent is the same as a cube root. So our final answer here will be log of the cube root of x squared over y times z. In the third expression, let's attack this like we did the previous one. Each of these coefficients that are in front, we can bring up as exponents. So we get that 4 log x is natural log of x to the 4th. The 1/4 natural log of y is natural log of y to the 1/4. And 3 natural log of z is natural log of z cubed. The first two terms are added together, so we can rewrite that as a product. We get natural log of x to the 4th times y to the 1/4. And now these two terms are subtracted, so we can write that as a quotient. So our final answer in that case would be natural log of x to the 4th times the 4th root of y over z cubed.